All right, how's it going? Guys doing okay? Hope this video goes okay. As I heard a little bit of feedback from the last one, a couple of suggestions and whatnot. So this one goes kind of smoothly, all good. We are on page number 170, I suppose. By the way, so page 170, it depends on which version of the workbook you have. There are a couple of subtly different versions of that workbook between my two classes. So around page 170, we're going to do even and odd functions. We're also going to do the next page, which is vertical asymptotes. So this should be a pretty quick video, and we'll roll that both together. This starts off with looking at, it looks like something that's maybe degree 4 or so. And we have what it is called an even function. Our definition of an even function is that if f of x is equal to f of negative x, then f is even. If we think about that in terms of stuff that we've seen before, if we've seen before, let's see here, like even if we've seen before y equals x squared, that ends up being an even degree, we know. And what happens is when we plug in negative x, when we do a horizontal reflection across the y-axis, then this, of course, is just going to be equal to itself, because when we reflect it across the x-axis, we have that horizontal symmetry. Sorry, across the y-axis, we have that horizontal symmetry. And when we square negative x, we return just to y is equal to x squared. So what we're going to do is we're going to substitute negative x for x in our function to test to see if it's even. And what happens with that? Even functions are symmetric with respect to the y-axis. So to classify this following function, sorry, let's go through this. The odd piece means if f of negative x is equal to the negative of f of x, it is defined as an odd function. So this ends up being, we have a vertical reflection and a horizontal reflection going on. Or does a horizontal reflection get to the same point as a vertical reflection? Odd functions are symmetric with respect to the origin. Come on, baby. Here we go. So odd functions are symmetric with respect to the origin. They look the same if they are reflected in both the x and y axis. It actually ends up being rotational symmetry. If we rotate it 180 degrees, do we get to the same place? And so that's our definition of an odd function. Y is equal to x to the 8. So let's do this first question. We start off by saying, okay, if this is the function f of x, if we want to think of it as f of x equals x to the 8, then f of negative x, and we consider what happens if we look at negative x. This will be equal to negative x all to the 8, which is, of course, x to the 8, which is, of course, f of x. Therefore, f of x is equal to f of negative x. Therefore, it is even. It's an even function is what we're saying. It's not just saying that it's even degree. It is not true that anything that's even degree is an even function. It has this symmetry about the y-axis is what makes it an even function. Number 2, let's look at this. Y is equal to x cubed plus 1 over x. If we consider that it's not just y, let's call it our function x, f of x, and we have x cubed plus 1 over x. And then we consider what happens if we take f at negative x. Remember that for it to be even, it ends up being equal it ends up being equal to our original function. And if it's odd, it's the negative of our original function. So then f of negative x is equal to, well, let's just substitute negative x and see what happens. Negative x cubed plus 1 over negative x, which is equal to the negative of x cubed minus 1 over x. And if I common factor out negative 1, this becomes negative of x cubed plus 1 over x. But that thing in the brackets is just f of x. So on the left side, we have f of negative x. On the right side, we have the negative of f of x. So therefore, this is what is called an odd function. And that's pretty much it. We will be using this when we put it all together for sketching. We're going to consider whether this function is an even or an odd. It ends up giving us some ideas about what it looks like. All right, next page, vertical asymptotes. We've already kind of seen this before, of course, but we are going to, once we get knee-deep into sketching, we are going to be considering what our vertical asymptotes are doing. It starts off with, given that f of x equals 1 over x squared, determine the limit as x goes to 0 of f of x. Clearly it is undefined. That limit does not exist when x is equal to 0. So we look at the left and the right hand limits. We look at the limits coming from below. X is equal to negative 0.1. So 1 over x squared is 100. The fact that we are squaring it means that we will no longer have a negative sign on here. And we have 10 million is this last one, which is the idea. When we approach it from above, when we approach it from the right, 1 over 0.1 squared ends up being 100. 1 over 0.01 squared is 10,000 again, and then 10 million. Because we have a left limit and a right limit, they're equal. The limit, we still, technically, we say it doesn't exist, but from both sides, it's approaching positive infinity. So that gives us our head around what this is going to look like when we're going to graph it. So our function will have a vertical asymptote at the line x equals a if we have any of the following limits. If x equals a from below is positive or negative infinity, f going to a from above is positive or negative infinity, or in general, x going to a is positive or negative infinity, we will have a vertical asymptote. So to find our vertical asymptotes, values of x, we make our denominator 0 and find the one-sided limits at these points. So we make our denominator 0 and we look at our one-sided limits. F of x equals 2 minus 5 over x minus 6 squared. Obviously, this is interesting around 6, so x goes to 6 from below of f of x. Equal, what is it going to equal? Well, we're going to have 2 minus 5 over this value now. 6, but we're talking about 6 from below. When we subtract 6, we get a very, very small number, but it ends up being negative. But once we square it, it doesn't matter that it was negative. Either way, when you square it, it's going to be a positive amount. So we have 2 minus 5 over this tiny, tiny number. This amount, this 5 over x minus 6 squared, this is going to go to negative infinity because it's subtracting. This is going to negative infinity. And so here we have that. Our limit as x goes to 6, but from above, of course, it's going to be 2 minus, again, it's going to be 2 minus positive infinity makes this equal to negative infinity also. So we have a vertical asymptote at 6, both, I don't know what the rest of this looks like, but at 6, this function will be doing this. In part B here, we have f of x equals x over x squared minus x minus 6. So your first instinct is correct. Let's factor that so we know what this denominator looks like, so we know what you're dealing with for values that are not permissible. And we have the limit as x goes to 2 from below, sorry, negative 2 from below of f of x. What is that going to equal? Well, let's consider if x is going to negative 2 from below. That is numbers like negative 2.001, right? It's less than negative 2. And we need to consider that when we are looking at what's going on in our function here. This is negative 2.001 plus 2. So this part here will be negative. This is negative. And then negative 2 minus 3 makes this negative. We have negative divided by negative times negative. It makes this quantity is going to be equal to, clearly we know it's infinite. Because the denominator is getting closer to 0. So this ends up being negative infinity as we go to negative 2 from below. When we look at the limit, x goes to negative 2, but from above or from the right side, when we look at this, what's going on with this? And so we just analyze what's going on with each of these pieces. When x goes to negative 2, but from above, that's numbers like negative 1.9. In this case, this will now be positive. Still negative up here, still negative over here. So this is negative divided by positive times negative. And so we end up with positive infinity as x goes to 2 from above. We're going to do the same thing for around 3. And the limit as x goes to 3 from below. X goes to 3 from below. This is now positive 3. So this is positive. This here is positive. And then we have 3 from below means like 2.9 minus 3. This will be a very small negative number. So positive divided by positive times negative. And so this ends up being negative infinity. Limit as x goes to 3, but from above. That means numbers like 3.001, something like that. And so when we consider that 3.01, numerator is positive, this factor is going to be positive, and 3.001 minus 3 is a very small but positive number, makes this limit is positive infinity. So for both of these asymptotes, on one side is going to positive infinity, on one side is going to negative infinity. And that's pretty much it. All good. Nice quick video. That's all that I have for here. Thanks.